Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Hello everyone, my name is Faisal Khalil and today we come up with another tutorial. So this tutorial is about Docker. Down the line in the software development life cycle, there are different cycles for sure, and we've been actually posting some video in sequence wise. So we have so far seen different technologies. For example, we have first seen the Git, and after the Git, we have seen that how you can build a pipeline with Jenkins, and you can automate a lot of stuff with Jenkins, even with the hook. And then we have seen when it comes to configure a different server for different environment, for example, a production environment, development environment, and all those different environments, we need sometime a lot of different server configurations and management. So manually or one by one, it could be very hard. For that, we have used actually Ansible, which is a configuration management tool. Then we have also seen that over the passage of time, a lot of companies are shifting toward cloud and creating resources from the console or front end. It's also again very tough. For that reason, we have used Terraform. So now down the line, the next stack is Docker. Well, the conceptually, this it is very important to get to know that why actually we need Docker, where it comes from, what is the history, what value it really added to the stack, and what would happen if we didn't have Docker. So to learning any concept or getting intuitively into the concept, it is very important that you ask some question that what would happen if this technology didn't come into the place? What extra value it added and how it's differentiate from the existing whatever available technology or whatever concept was available before. And when you actually really understand the need of anything, then you really understand that which kind of need it's actually fulfilling and how it's giving extra edge or a new value. Similarly, we're gonna draw something. Hopefully that I can draw something with mouse. So, for example, there are multiple benefits Docker is giving. We'll discuss shortly. But what does actually Docker do? First, we need to understand what does Docker do, and then we'll discuss that what benefit it's adding. So let's draw some stuff here. For example, whenever I need to do anything in our example, we have seen that we had to create a application artifact, which means that we have written some code, we have done some analysis on it, that we have tested this code. Now we have created the artifact. Artifact means that in Windows operating system, when you download a software, there comes a exe file. This is the artifact. In the Java application, you come application.var. In Python, normally you don't have the application structure. So similarly, on web-based application, you have URL as an end product. So it depends for the technology, but yeah. First thing first, that how Docker works is that normally, let's say that I need to do something and I have to run my application. Let's take our example scenario that I'm offering some insurance comparison, or let's say like that, have fun comparison website or web app. What it does, it gives you comparison in different range. Let's first discuss that. Let's say I'm giving the comparison of insurance in your area or in your country. If you want to get some insurance, you can go there, you can check different. Let's say it's a Java-based application, as we've been doing everything with Java, and we have app here. For the app, we need to install Tomcat, as we have seen in our previous tutorials, and on the base level, we have operating system. We have operating system on top of operating. Let's say like that. I have 50 cores, not 7 cores. I have 200 GBs of RAM. It's a big server. Now you go 20 years ago, whenever you need to deploy your application. Let's say is it if it is regardless if it is a web application or based on Tomcat or Nginx or whatever application it is, you need to buy a physical server. What was happening is that you had big warehouses. They rent you a small PC or one PC. You name it as a server, and somehow you deploy. But the thing is that things were in much uncertainty or in unpredictability, because you never know that your application is going to be a successful, your business is going to a successful business or not. That's it. Like that, my insurance or uh, insurance comparison portal. Now this is my business. So now, for example, it could be the case that my business is very successful and I get a lot of user. For example, I get a lot of traffic into the application in on website, and there are many members. But it could be the reason that, or it could be the possibility that there are not much traffic, but we need to have some dedicated resources pegged or bounded already. Why? Because you never know. What people were doing in the past, that they had tendencies to rent big, you know, these big kind of PCs and servers, and sometimes they were overkilled. Over the passage of time, people come up with these smarter ideas. They said that we should do hardware level virtualization. For example, over the passage of time, I am thinking that I'm going to create a multiple apps. This is not one app. I will give life insurance. I will give car insurance, and I will also give the comparison of, let's say like that, cars. If someone want to buy a sale of cars, and I'm also going to give the comparison or the old car parts. Now let's say, for example, for each we are planning that we would have a different name. For example, life.app.com. We would have car.app. So you can see that we have different parts.app.com. So now we have different three apps. For example, for every app, we would need a tool or way to do this. Either we can always go for another server, which is very, very costlier. But one option we have something like VirtualBox or VMware or VirtualBox, which I can really show you. If I go here, box. So yeah, Oracle box I have already installed. Now I have three windows installed. One is Debian and three other windows. Like in total, I have 4 windows. Nice. What I can do that I'm on my laptop, and on this laptop I have installed these window. Even I can create more window. But what is going to happen? For example, in total I have this much stuff here, and and now I'm sharing. Now what I can do, I can create a sub kind of small windows, right? And I can say that I have two small operating system here. within the big operating system. But what they are doing here, they have something called release hypervisor. So what is the hypervisor does? The hypervisor is the technology, is a kind of hypervisor is a technology which really do this virtualization that shares the hardware resources of my laptop, right? It shares my it shares my laptop, which is 50 core and 200 GBs, and might be it's gonna create a one window which is only a 4 core and 5 GB RAM, and on top then it has, for example, Java and Tomcat already installed, and then for example, you know, and operating system, whatever operating system I need, it could also give me operating system as well. So this is now kind of a good stuff is going on in with respect like OS is equal to, for example, Ubuntu. So that could be the case. Now the virtualization makes our life a little bit easier, but still, what's happening here is that, for example, on the second server, first thing first, you need to really install that these computer really works on port. Port is nothing but a hardware level physical connection where any software runs. And when port of busy, no other software can use the port. For example, for every new different app for the company or the sub app of the company, I need to install second time a Tomcat, second time a Java, second time a operating system, right? For that, what I have done, which hypervisor or the virtualization, I have sliced my hardware with the virtualization or hypervisor technique into the different pieces. It could be 10 pieces based on your use case. Now that's essentially conceptually called hardware level virtualization. That calls hardware level virtualization. There is also something called software level virtualization. We'll discuss it. Yeah, OS level, operating system level virtualization. We'll discuss that soon. Now, what happened is that that idea came into the market and what people start using it, but still it is not a very fancy idea. This is not a very good idea. We have some operating system that could be Windows or whatever it is. On top of it, it's a hypervisor. It's slicing my hardware resources. For example, if I got 50, it can slice into the 5 PCs, and on each PC, I can really go run my traffic. Now, there are some problems. So in the market, everything comes due to some problems. Now the problem is that when I restart my PC, right, I have to make this application always open. Then if I have to restart or start the PCs, it take a lot of time. For example, I'll at least take 1 minute to 2 minutes, and these kind of stuff, right? And it is not very efficient. I would tell you, if you had this experience with this virtual machine, sometimes they do glitch, sometimes it is networking problems, sometimes there are some other problems, well, virtualization was kind of one hardware virtualization was kind of one solution, but it is not a very good solution. Then people come up with a smarter idea that why not then people come up with the smarter idea that why not we should do operating system virtualization. The virtualization, so this thing, the capacity of the computer, this is my laptop, for example, a big laptop with big stuff. I have here the hypervisor already. For example, I have operating system, Windows, or regardless what operating system, Ubuntu, Linux, whatever. Okay, I can have anything here. Now they say, why not we have baseline operating system, which is Linux or Windows. We don't care. We don't use any hardware resources at all. The base kernel of the window, for example, for the running a window, we need a lot of resources. For running a Linux, we need to create a directory structure like you have might have seen bin, lib, kernel, Linux kernel, whatever. They say that we create another smart system, and that system, what does that system? It create a container. It create a container. So this is really a very fascinating idea, not? Why it's a very fascinating idea? For example, with help of any containerization technology, which we can call container runtime, which we could call container runtime, or normally we call this. There are many different options in the market, and Docker is one of them. What we are learning, we just install one software, not a very heavy software, that called containerization. This is a big stuff here. And with that software, what we can do is we can easily create a multiple containers here. Great. We can create a multiple containers here. So, for example, just pull this up a bit. This is container runtime running here. On the baseline, there is a window. Here is the power of this big laptop. Here we have this window here, right? We have container number 1 here. And we could have container number 2. We have some container here, right? We have some container here, and the runtime is Docker. Now, similar thing, whatever scenario we got here, we have here too. Very similar scenario, right? We have all those things. We have mentioned operating system, we have Java, we have whatever. But now the thing is that we don't have any hardware resources. We can use every container 1, container 2, container 3, or container 100. They act like completely as a complete operating system, but they are not operating system. They are very lightweight. They just barely can use like 100 to 100,000, 100 to 1000 GB only, memory wise, and RAM barely nothing. So what if I would say that they give you MBs storage, 1 to 100 GB RAM, GB RAM. What if I say that they gives you dynamically, if you create 100 of different Dockers, they are very lightweight. They are just like 100 MB or 5 to 10 MB even. The less, the minimal is the 7 MB in the word of container. They don't carry any window. They doesn't care about the window because they share one big column here, which is the operating system. They just share this thing here, the baseline, and every new container is very lightweight, and thus you can create multiple container and you can deploy multiple server. And what could happen here, that one of your application could go here, second of your application could come here, and might be I have another container, and third of your application could run here. They could have completely different dependencies, different Tomcat, different version, whatever. And the beautiful thing is that they are expandable, they are elastic. They could shrink, they could expand. If there is more traffic, they automatically figure out to fetch more resources, right? Dynamically, based on the traffic, based on the load. This automatic load balancing, operating level virtualization gives this concept a revolution um, of the operationalization of code, or the DevOps. And nowadays, a modern DevOps really a modern life cycle of the software development. In the operational side, everything runs on the containers, nothing else. And this concept really gives a lot of edge now. And what you can do, you can just create any operating system on the baseline, because the containers are operating system agnostic. They don't care about the operating system. They use those resources. But the beautiful thing is that here, the container, you can have Ubuntu container, you can have window container, regardless what window is on the baseline, because they create a virtualization on the top. They just share the resources, and you can have any kind of container. Now if you go to the website hub.docker.com, you would see the image of any window, like any window, any operating system you have in your mind: Alpine, Ubuntu, RHL, Red Hat, Fedora, SUSE, I don't know, you name it. Any kind of image, you just name it. It would be available on docker.hub.com. This is an online website where you can get pre-built images like a window. What is the image? What is the Docker image? Docker image is nothing. For example, I take your scenario, you want to install a window on your operating system or on a laptop. What you need a window image. You just get that image, you boot it on USB, you install the window. Similarly, for any kind of image, you need that image for the Docker container. Container is nothing, but it is very bare minimum Windows. Getting Windows capability from the down the line. So if I go here, Docker, what, hub. You see here, you can search body anything. So, for example, I search here Ubuntu operating system, right? Here you see the official 1000K. Oh, this is just a window. What you need to do, you go to the command line, you write docker pull Ubuntu. A brand new perfect window installed, available to you. For example, sometimes you also have a lot of images coming from the public and coming from the people of the community, which is predefined and pre-configured. The good thing about this stuff is that you even can customize everything. You can get the Ubuntu, you can install your required software dependencies, whatever you needed, and you can again pull up with your username and password to this registry, or there is another website, and you can call that and you can pull that image which has dedicated ID to any system. What extra benefit it gives? Now there is a list of benefit. It has created the automatic load balancing, increase and decrease of the container size, which is highly elastic. And conceptually, you don't need to give a lot of money. It's spared a lot of your money, your effort, and your efficiency. In all these three categories, it gives you extra benefits. How? Now you can only pay, or your container only use that much of resources which are needed to operate your traffic. Based on traffic, if traffic increases, it expands or automatically shrinks. The speed wise, to start a container, it's a blink of eye. It's a fraction of a second. You don't have to worry about that. For the virtual machine, there was a whole another story. Now, actually, practically, there is other tools like Kubernetes, which are the tools to manage these big containers, like multiple containers and communication of container and management of container, duplication of container, backup of the container. If one container is get destroyed for some reason, how it automatically create a new container with the fraction of second. These kind of stuff practically nowadays are done by the Kubernetes or orchestration tools, or there are some advanced topics. But right now, this whole industry, this whole DevOps topic is revolutionized with the advent of this Docker container or any containerization tool.
And this is very fascinating. It saves you a lot of effort, a lot of money, a lot of speed, a lot of time, and it's just a fascinating idea. And it is highly adopted by the industry. You would never see any DevOps topic or job in the industry which runs without Dockers. Or you would never see any enterprise or any good organization which runs or deploy their application without a Docker. So that's the story of Docker. That's the history of the Docker. That's how Docker came into the picture, and that's how it's serving. That's how it's adding to the stack, adding value to the stack. And yeah, the one another thing which is very important, last word, that it's also, in a way that, for example, I'm doing some stuff programming on my laptop. I have created some code, I have installed some dependencies, Python run this, and in the end, everything I have configured some stuff, I have include and exclude some stuff, and in the end, on my laptop, everything works fine. But what if I want to show this to the world? What if I send it to the another country, some other developer is sitting, and I send the code and say, "Oh, the code you have sent, it doesn't work for me," and you said, "Okay, it's worked for me." And he asks you which machine you're using. I'm saying I'm using Windows, and you say, "Oh, I'm using Mac, or I'm using the Ubuntu or the Linux." Okay, to run this software, I have to first go to the window. I can buy a new laptop. I install. Ask you multiple times which thing exactly version wise you have installed. I install that. I figure this out, and then this application will run. And with Docker, no problem. Docker is something completely encapsulated in one word, and it's agnostic from the window. It doesn't care about the window. It's just getting the resources of the window to run it for sure, but it doesn't care about the window and the kernel and the baseline hardware or the architecture. It is Linux, is Windows, it is architecture 64 or 32-bit, whatever technology it's using at the hardware level. Don't worry. And if I package my container from my laptop and it send it to the any part of world, it would work seamlessly the similar way which it works for me. And that is the another revolutionizing or very good benefit of the Docker. So that's all about the Docker. Stay tuned, like the subscribe and hit the bell icon if you really want more videos like that, or if you really enjoying or you think that it's adding the value, then please subscribe it. I'll come up with another topic, which is practical handles on Docker, how you create container, customized container, and how you then deploy on the registry, and then we come up with the Kubernetes topic. Thank you very much for watching. Bye.